Yeah. Uh, Good morning, students. So the next topic is a thermoelectric power conversion. The topic is thermoelectric power conversion. This course material on this topic I have sent to your college email ID, and also in the Google Class this as under the heading thermoelectric power conversion notes, and that I have uploaded in the Google Classroom also. You can download and you can keep it as a in some file under this name. How you are going to store the separate sheets in a file, a collection of notes. Uh, like that, you can uh, download this file and keep it in a particular folder, so that while studying, and also give the number 1, 2, 3, 4, 5, like that. First page, second page, third page, like that number you give it, so that it is easy for you to refer. Reading it becomes easy. Otherwise, in the computer, a lot of information here and there will be there. At the time of reading, downloading, searching, that itself takes half a day. During examination, you will not be having such more. You will not be having any time at all. Just page number 1 to page number 80, 90 continuously should be in a position to read it. In that way, you collect the course material or the notes of PDF and keep it ready. Or you can take the print. For still more convenient, you can take the printout and keep it in a file, hard file, hard copy file. It will be more easy to read. Computer always just to open the computer, switch on the computer, and opening that file folder and turning here and there, up, scrolling down on horizontal, up and down. There itself, you will be tired, and it will be losing interest there. So that is the hard copy form. If you take the printout and if you go on add the printout sheets, it will be better. Or else that is also not necessary. Just I am sending this PDF soft material and etc. Whichever the good figures are there, more information I am sending it. More than this, more than this, the energy engineering book written according to VTU syllabus by Hegde, that only one book is sufficient to complete for the examination point of view. It is the page number 1 to last. Continuous notes. It is like a very beautiful, good notes, no mistakes, and systematic. It will be very, you feel very easy to read that one. In the class, you just attend, get the exposure, how to uh, what is the significant points in a particular topic, uh, etc. Like that, you can get awareness by attending the online classes. Yes, Rajat Kumar, anything is there? Not able to listen, sir. Some noise is coming, sir. Okay, what has happened? Anybody can speak. As Rajat Kumar has put message, not able to listen. What has happened? Uh, yes, sir. Now clear. Okay, right. Thank you, Rajat Kumar. Let us go ahead. Uh, so now I just will say, because of not clear, some general thing I was discussing. Uh, uh, about the study and preparation. Today's topic is thermoelectric power conversion. That is the topic. In this topic, as the name says, thermoelectric power conversion. Anyhow, conversion, power also, the keyword now for the today's topic is thermoelectric. Thermo means what? Heat. Electric means electricity, you know that one. Conversion of heat into electricity is the basic principle in basic idea present in this heading, thermoelectric heat, electric heat converting, thermoelectric power conversion. So converting heat into electricity as a power is the thermoelectric power conversion. How it is achieved? It is nothing. It is not a new one. Already in your PUC physics, in depth you have studied this one. Here you will not study to that depth at all. But here application orientation you will study engineering point of view, advantage, disadvantage, production, technology, manufacturing, fabric. In this orientation, you study, but the science behind this already in PUC, you have studied a lot on this one. That is nothing but a Seebeck effect, Peltier effect, all these things. The same thing once again coming here. It is about all these things. Now I am going to open that uh, course notes, this thermoelectric notes. You see that one. All of you put your USA number in the chat box. All of you put your USA number in the chat box. Now that thermoelectric power conversion scanned page I have opened. Is it does it have does this has appeared on your screen also? Any Rajat Kumar, you put it in chat box. Yes or no? I will minimize this and I will check. Okay, thank you, Rajat Kumar. Yes. Now let me continue. Thermoelectric power conversion. Let me come back to this. Let me take the sketch. This figure you see here, what it is a thermocouple. Thermocouple, you know this one already. Uh, Actual thermocouple itself we have used in energy lab, materials, this one, metallurgy lab, and heat transfer lab, fluid mechanics lab. Thermocouple already have used. Science behind that thermocouple at the long back you have an exposure. The type of the sketches different, one textbook to another textbook they will change the type, writing the figure. Somebody will write a circle like this, somebody will write in an oval shape, somebody will write it in a rectangle shape, whatever it is the shape. The shape of the sketch is not a matter here, the principle is important here. Now you look this elementary thermocouple. uh, See here, this is material A. Let me call that one as P type. Okay. That is this one. This is this one. This is material B. That is this one completely. Material A is this one. I will erase that one now. Okay, let me take that one. And these two are joined. Here they have joined. This is hot junction. They call this one. They call this one as hot junction. And this is cold junction. And plus these are all, that is this one, ions. They call simply as the carrier, ions, current carrier, electrons. Some chemistry technology will come here. And since this is the material A, they call this one as a P type. And they call this right side one as an N type. Uh, Positive and negative. And these are all negative, like this. These are different materials, uh, two different conductors, also semiconductors, are joined at two ends, and they form a pair or a couple. Okay. And look at this. This side, this side is heat input, whereas this side is heat rejected, that is low cooling. Say H indicates hot junction, C indicates cold junction. Two wires are taken, joined at on either end, and it is immersed in hot junction. This is immersed in cold junction. Just by doing that, what happens is these electrons carriers are there, no? Uh, what they will do is, see, these electron carriers, they start moving like this. Direction is this one, hot junction to cold junction. This is hot, this is cold, in this direction. Like this, the carrier starts moving because of the difference in temperature. Because of the difference in temperature, the heat starts transferring from one point to another point in a particular direction through carriers. This difference in temperature is called as a temperature gradients. So it's somewhere here, or somewhere here. If mm, uh, uh, at at here the electromotive force is generated. That is voltage. Electromotive force is generated here at this point. Then you connect an electrical circuit. You connect an electrical circuit. Then in that electrical circuit, the EMF will flow as a current. The movement of this electric carriers is nothing but sorry, current generation. And there it is a load, resistance of the load. This is the EMF, E, and this is the current. This is a very simple basic circuit. Already you know that one, electrical. So this thing, when this electrical current flows through this one, okay, electrical power is generated. Look at this, how simple conversion of one form of energy into another form of energy. That is the best form of the energy, electrical energy. So easy. This one in the line diagram can be represented like this: heat input, then heat rejected. Simply electrical power comes out like this. Now, the same thing it can also be represented like this: hard junction, that is a battery type contact potential, cold junction, another, and the current flows in this direction. And because of this hot junction, the G generator resistance, generator resistance, and this is the EMF. The current starts flowing like this in this direction. That's all. So once the current is flowing, we can use that electrical power for our any application, for driving the motor, lifting any object, or iron hitting the iron box, and electric stove, and using the current, storing the current in a battery, lifting in escalators, lift, etc. Wherever there is a electric vehicle, wherever it is necessary, we can use that one. Now, this is about this one. The thing is here, the power availability is very less, and it is having advantage and disadvantages also. Now let us look about its science behind this uh, through mathematical equation, electrical technology. Uh, Look at this. This is the thermocouple, that formation of that two wires. We call that as a thermocouple. Thermocouple produces the electromotive force. That electromotive force is indirectly converted into measure the temperature, like that. So the principle of this effect is called the Seebeck effect. Uh, it is discovered in 1821 by German scientist. What does it says? It is whenever there is a mm, temperature difference between the two junctions in a loop made up of two dissimilar conductor. Look at this. This is very important. Dissimilar conductor. Thermal electromotive force is produced in the loop. Such a loop is known as thermocouple. Okay. And see, this is the power. Power is equal to difference in heat transfer. Heat transfer at the hot junction minus heat transfer at the cold junction. The difference is the power. Such a beautiful equation it is. And also by electrical, we know that by Ohm's law, uh, power is equal to that is V is equal to R into I, and also power is equal to voltage into current. And by that, it is I square into RL. Uh, it is a misprint there. This is a correct equation. P is equal to I square into R, and also this is equal to, we know that V into I. We know this also, and V is equal to R into I. This is Ohm's law. This we know that one. Uh, so this power, you concentrate on wherever I am writing. Okay, this power P is proportional to delta T to the power of 2. So QH is heat flow rate into hot junction. QC is dissipated heat flow rate from the cold junction. Delta T is difference in temperature. Hot junction temperature minus cold junction temperature. So uh, we know this TH, we know TC, so delta T is known, and somehow we can R we can measure by rheostat. Current can be measured by ammeter, so power can be calculated. Or QC you measure, QH you measure, by that also power you can calculate. The so interesting science in this one. So finally, so if R is a constant for the given material, and this I ammeter rate is used. By using ammeter we can measure I. So P is equal to I square R. It is electrical engineering. In first year you have derived this one. So P can be calculated. Power can be calculated. Now look at this further. The open circuit EMF of the thermocouple is also given by this equation. E is equal to delta alpha delta T. Then what is this delta alpha? Delta alpha is difference. What is the difference? Alpha A minus alpha B. It means Seebeck coefficient for junction of material A and B. Hmm. So alpha A means absolute Seebeck coefficient for material A, voltage per Kelvin. Alpha B is absolute Seebeck coefficient for material B, voltage per Kelvin. So Z is equal to this equation. So alpha A minus alpha B whole square divided by square root of rho A into Ka plus square root of rho B into Kb whole square, where rho is the resistivity of the material, and A and B indicates the material A and material B type. In the unit is ohm meter, and Ka, Kb are thermal conductivity in watt per meter per Kelvin. Seebeck effect can be positive or negative. High magnitude of Z requires two materials with wide difference of absolute Seebeck coefficient. For high efficiency, ZT should be as high as possible. The power output can also be given as like this: delta T, delta alpha, delta T into I minus Rg I square minus RL I square. See, this Rg I square power wasted in the heat source generating. So that should be subtracted from this one. It is nothing but a heat wastage, like that. Uh, that should be equal to RL I square. For maximum power output, RL should be equal to Rg. Therefore, what happens? You put RL is equal to Rg. If you put, what happens? RL. You put here RL. Here, this is so you make it as RL. Then this term and this term get cancelled. So you are left with this much. P is equal to this much. You are left with this much. P is equal to delta alpha delta T into I, this much. So there, from this, I is equal to delta alpha into delta T divided by 2Rg. Okay. Uh, by using this equation. Now, maximum output power P maximum is given by this one, I square Rg Okay. So by with this, you substitute I here. In place of I, you put this one. So you are going to get this type of equation. But for this E, you can write like this: delta alpha square delta T square by 4 RG. You can write it P maximum. So this is the important equation. So this equation, you uh, reproduce it. Okay, this one. So this is the power maximum power available equation for the thermoelectric conversion device. Now let us look some other points. Uh, it converts heat directly into electricity through thermoelectric effect. Its salient features compared to other methods are advantage, compactness, lightweight, noiseless operation, no moving parts, highly reliable. Highly reliable means guarantee. The reliable word is the most important in the mechanical engineering. Highly reliable. It has the lowest maintenance of any commercial power source and can also be operated by low grade waste heat less than 20 degrees Celsius. It is ideally suited for remote and harsh environments. Uh, it is being intended for high-tech applications associated with aerospace, military, telecommunication, and control of unmanned vehicle monitored from a remote location. It is designed for 20 years of service life. See, these things advantage. These are advantages. And basic principle is thermoelectric power is Seebeck effect. So that is this one. This is the basic principle. And the equation is this one. P is equal to QH minus QC, that is equal to I square R. Further, it is the finally this is the equation. P maximum to delta alpha square delta T square by 4RG. That's the. So this much today you practice it. I have sent this to your email ID. From you can download it. You can see that one. I will keep it open. This one. This figure you can write it. I'm going to clear everything. If you have any doubt, you can ask me. With this, the explanation of all these things, it is over. Uh, if you have any doubt, you can ask. Uh, if you don't have anything to ask, you write the figure for this one. I'll keep it open. You write this figure. Practice this figure in the remaining time, and also put your if you put your user number in the chat box, it is enough. Only one time you have to put it. And this variable also write it. This derivation. So now you take write this figure for. I will keep it open for 6 to 8 minutes. Afterwards, the equation another 6, 7, 8 minutes. Uh, that's all. So if you are opening from your computer, email, if you download there itself, you are interested to study, that's also fine. Then in such cases, you can quit the class. You can class ends. You can with this class ends. But however, I will keep it open till 11:50. Sorry, 12:50. If you are having any doubt, if anybody want to discuss, I will give time, and it will be practice for you. From my side, I will have to take care for you to practice this one. You practice it till 12:50, 12:40. 10 minutes is buffer time. And your test 3 is 7, 8, 9, and the portion is uh, module 4 half, module 5 complete. Module 4 and module 5 portion for the test. I'll put it in the chat box. Yes. In the next class, anybody remind me to discuss case study. I have already in-depth discussed. Can you guess case study topic? I have stressed a lot. Which topic I have stressed a lot? Where I have visited. I have shown the photograph of all those things. Anybody can put that in chat box. And also officially to discuss to stay in the next class. I will tell that one. You remind me just for curiosity's sake to let me know how alert and how aware you are to guess the because I will be stressing while explaining the important one, significant one, most application or something. Uh, some case study, case studies also have used the word. You can guess what it may be case study. Okay, so uh, now in the rest of the time, just for curiosity's sake, let me ask you. Uh, you can now video. You can on it. Turn on your video. Could you turn on your video? Yes, sir, no, please. Could you turn on your video so that I can see your face? Anybody, Rajat Kumar, Pawan, Kiran, Shobit, Subramanya, okay, Rishabh Pandey, Chaitanya, Ishant or Sagar, Umesh are there, Nihar, T. Rohan, Vidyan Prakash, Sagar Chivi, Rajat Kumar, no webcams are okay, no problem. Those are having facility, they can turn. But by this time, we should have a video and all this one, facilities. Laptop, computer with video. Desktop computer with webcam is the better solution for study purpose. Not the laptop. Laptop is not at all advisable. Remember this.